Python allows us to create small anonymous functions at runtime called Lambda. Lambda functions are a great Python tool, enabling us to quickly insert some functionality into our code, especially in places that would not allow the definition of a regular function. You know, using the def keyword, the return statement, and all that. Unlike regular functions, you can embed a Lambda function wherever you want inside your code, and you don't need a return statement to output something from that function. Although not mandatory, you can assign a Lambda function to a variable, so you can use that variable further into the program. If you don't, then the Lambda function will run right there where it has been created, then the result is thrown away. Without further ado, let's see the general syntax for Lambda functions and then some examples. So we have something like this: Lambda, argument 1, argument 2 separated by comma, and so on up to argument n, a colon, and then expression using arguments. Okay, let's do a couple of examples in the Python interpreter shell, and let's assign the Lambda function to a variable in each example. So first, let's say a equals lambda x comma y. These are the function arguments, a colon, and let's say x times y. And that's the Lambda function definition. Now let's check that this is indeed a function. Let's see a. So you can see function lambda and the memory location. Let's do a type on a. So type of a, it's function. It is a function. Okay, cool. Now let's call our function and give it some arguments to multiply. Let's say a of 2 and 10. We got 20. Okay, cool. Of 100 and 100. And we get 10,000. Okay, great, it works. See how easy it is? Now let's do another example. Hold on tight, this will be a nice one. Let's combine the lambda function and the list comprehension, in which we'll have a nested for loop. But first, let's do this old-fashioned using a regular function and a regular for loop syntax. Let's say that we want to obtain a list with all the results of multiplying each element in the list generated by a range of 10, so 0 through 9, with each element in the list generated by a range of 5, meaning 0 to 4, and concatenate this list with a list given as argument to the function. How would we normally do this? Well, we would create a function, a for loop nested inside another for loop, and then return the list of results concatenated with the list we passed as an argument. So let me write this first. Def, let's call our function myfunc of list. So this function accepts only one parameter, a list. Okay, colon, an indent. Let's say prod underscore list equals empty list. So we initialized an empty list to store the product results. Now the for loops for x in range of 10, colon, then the nested for loop for y in range of 5. Sorry, I got this all wrong. Let me use the up arrow key to get back. Okay, for x in range 10, for y in range 5. I didn't use the colon. Okay. Now, inside this nested for loop, we are going to do the math. So product equals x times y. We are storing each result in the product variable. Okay. And then prod list dot append of product. So we append each value to the prod list. Okay. Finally, we should have a return statement. So return. We said that we wanted to concatenate the prod list. So prod list with the list we pass as an argument to the function. So plus list. Okay. Now let's call the function and pass a list as an argument. So myfunc, and let's use some elements for this list: 100, 101 and 102. Okay, so we got the expected result, a list made of the multiplication results, at the end of which we added three elements, 100, 101, and 102. Now we can achieve the same result with just one line of code, using the lambda function and list comprehension. Let me type in the line of code first. So let's say b equals lambda list, because this is the only argument this function takes. Now for the list comprehension, we use the square brackets, so x times y for x in range of 10. Now for the nested for loop, for y in range of 5, we should concatenate this list with the list given as argument, so plus list. And that's it. So after the lambda keyword, we have a single argument, list. Then instead of initializing a list and writing the for loops and appending the results to that list, we use the list comprehension with a for loop nested in another for loop without having the need for colons or indentation. Finally, we added our own list to the list created by the list comprehension, and that's it. Now let's check the results. So let's use the same list as we did earlier, so B. As you can see, we achieved the same result with a lambda function and a list comprehension using one line of code instead of 1, 2, 3, 4, 5, 6, 7 lines of code. Lambda functions are widely used in conjunction with three other Python functions, map, filter, and reduce. We will discuss them in the next lecture.